Hey everybody, so how is SpaceX actually going to get to Mars? Well, let's talk about it. First off, you should have an understanding of Newton's laws. So Newton's first law states that an object in motion or at rest will stay in those positions or movements unless a force acts upon it. Newton's second law gets into acceleration. And then Newton's third law, you've probably heard of it, for every action, there's an equal and opposite reaction. Basically, that's how a rocket works. The thrust goes down and the rocket goes up. Or think of yourself, if you're standing on a skateboard and you're facing a wall, and if you push the wall, which direction are you going to go? You're going to go the other direction. So anyway, so SpaceX will launch a rocket and leave Earth's atmosphere and get into a low Earth orbit. So it's not going to get into space yet. It's going to get into orbit around Earth. And the speed it needs to get into that orbit is 17,000 miles per hour. And when you're in a low Earth orbit, you're basically in a constant free fall. You're just falling around Earth. It's like a balance. So you're getting pulled by Earth, but you also have a sideways velocity. And once again, when you reach 17,000 miles per hour, that's also how fast the International Space Station is moving. Once again, you're in a constant free fall. You could also say that Earth is constantly falling around the sun, much faster though. I think it's like 18 and a half miles per second. So anyways, SpaceX will refuel while it's in low Earth orbit, also called LEO, and then it'll continue on to Mars. But in order to do that, it needs to reach escape velocity. And for Earth's gravitational pull, escape velocity is 25,000 miles per hour. And then it'll continue on to Mars. It also has to make sure that it lines up the orbits as well. So you just can't go to Mars. You actually have to make sure the orbits of Earth and Mars are in a good position, because what if Mars is on one side of the sun while Earth is on the other? So you have to make sure the positions are correct. And even when you get the positions correct, it still is an 8-month mission right now. There is ideas of getting to higher speeds to shorten the trip to Mars. So going back to Newton's first law, once you're going 25 miles per hour or 25,000 miles per hour or faster, you stay at that speed when you're in space. There's no forces acting on the spacecraft. So there's no friction, there's no air, there's no gravity. So once you're going really, really fast, you keep going fast. On Earth, if you throw a baseball or a football, there's air resistance, there's friction, there's gravity, all that kind of stuff. But not going to Mars. You'll just keep going. So they'll keep going at a really high speed until they reach Mars. Pretty cool, eh? Hope that made sense. Stay curious.